Hi everyone, my name is Mahads and today I'm going to speak about a virus that many of us are familiar with, although we might not know it by its scientific name. This virus is the varicella zoster virus, or VZV for short, and it's the culprit behind chickenpox and shingles. Now you might hear herpes virus and immediately think of cold sores, but VZV is part of that same family, specifically the alpha herpes virinae subfamily, which also includes other viruses that stay in our bodies for life. VZV is a virus, which means it's much smaller and simpler in structure compared to bacteria. It doesn't have a cell wall at all. Instead, it's an enveloped virus, which means it's wrapped in a lipid membrane stolen from the host cell when it was made. Inside this envelope is a protein shell that protects the virus's genetic material, which is its DNA. VZV's DNA is double-stranded and it's about 125,000 base pairs long, which is relatively large for a virus. This DNA encodes for around 70 different proteins, each with a specific role in the virus's life cycle and its ability to cause disease. So, what does VZV actually do in the body? In children, it causes chickenpox, which you can remember as a super itchy rash with red spots and blisters. But that's not all VZV can do. After causing chickenpox, the virus doesn't just disappear. It actually goes into hiding in the nerve cells where it can stay dormant for many years, even decades. Later in life, when the immune system gets weakened, maybe because of stress, illness, or just simply aging, VZV can reactivate and cause shingles, which is a painful rash that usually affects one side of the body. What's interesting about this virus is how highly contagious it is. It means that if you're exposed to someone with chickenpox or shingles, there's a good chance to catch it if you haven't been vaccinated or haven't had chickenpox before. The virus spreads through respiratory droplets. When an infected person coughs or sneezes, it can also spread through the direct contact with the fluid from the blisters. This is why outbreaks can spread so quickly in places like schools or daycare centers where kids are just so close with each other. So it all starts when the virus enters our body, typically through the mucous membranes in our nose or mouth, basically around the soft, moist areas that are our first line of defense against invaders. Once VZV gets past these barriers, it doesn't waste any time. So unlike gram-negative bacteria, which might use pili to stick to our cells, VZV takes a more direct approach. And the virus uses its envelope proteins, specifically glycoproteins, to fuse with the host cell membrane. This fusion process is kind of like opening a door, which allows the virus to slip its genetic material into the cell's interior. So once inside VZV's DNA, it's transported into the nucleus of the host cell, which acts as a cell's control center. So the virus hijacks the cell's machinery, which turns it into like a factory, which produces more viruses. And in this phase, VZV is basically replicating its DNA and making the proteins. But here's the thing. The person still doesn't feel anything yet. This is the incubation period, which can last from around 10 to 21 days. And this is where the virus quietly multiplies in the body, especially in the lymph nodes and the upper respiratory tract, without showing any obvious symptoms. But then the next stage, which is viremia, is where the virus enters the bloodstream and starts to spread throughout the body. So it's like a floodgate, and it opens suddenly, and the virus can reach organs and tissues far beyond when it first entered. One of the virus's favorite destinations is the skin, where it causes the chickenpox, the rash. It starts as small red spots that quickly turn into fluid-filled blisters. And the blisters can appear all over the body, and they're incredibly itchy, which is one of the most annoying parts of the illness. VZV's story doesn't end with chickenpox. After the immune system fights off the initial infection, the virus doesn't go yet. It retreats into the dorsal root ganglia, which is a cluster of nerve cells located around the spinal cord, and it enters a state of latency, which is a dormant state, and the virus doesn't cause any symptoms, and it can stay this way for many years. It waits for the right conditions, like when the immune system is weakened, to reactivate and cause shingles. Shingles is a different compared to chickenpox. So chickenpox affects the skin, whilst shingles involves the nerves, which is why it's so painful. So the rash typically appears on one side of the body, often in a striped pattern, and the pain can be intense and can last even after the rash clears up. The ability of VZV to hide in the body and then re-emerge later is what makes it so persistent and challenging to deal with. So one of the most effective ways to protect ourselves from VZV is the varicella vaccine, also known as Varivax. The vaccine is a live attenuated vaccine, which means it contains a version of the virus that has been weakened so it doesn't cause disease in healthy individuals. So the idea here is to expose the immune system to the virus in a safe way so it can learn to recognize and fight off the real thing if the person ever encounters it. So when we get vaccinated, the immune system responds to the viral envelope proteins in the vaccine. And these proteins are crucial for the virus to enter the cells. And by training the immune system to recognize them, the vaccine gives a head start in defending against VZV. So the varicella vaccine protects against the initial chickenpox infection and also reduces the risk of shingles later in life by boosting the immune memory against VZV. The impact of this vaccine has been incredible. So in countries where the varicella vaccine is part of the normal routine of the childhood vaccination schedule, chickenpox cases have plummeted by over 90%. So it isn't just about avoiding an uncomfortable illness. It's a serious case about individual protection. High vaccination rates also contribute to herd immunity. This means that even people who can't get vaccinated, like newborns or those with certain medical conditions, can be protected because the virus can't spread as easily in the community. Another interesting development is the MMRV vaccine, which combines protection against measles, mumps, rubella, and varicella into a single shot. This combination vaccine is a win-win because it kind of simplifies the immunization process for kids and their parents. Instead of getting multiple shots, children can get protection from 4 diseases at once, making it easier to keep up with, and also by ensuring high coverage with the MMRV vaccine. Both Niminrex and varicella vaccines are highly effective in preventing the diseases that they are designed to target, but they work against very different types of pathogens. Niminrex is a vaccine that targets Neisseria meningitis, a bacterium responsible for causing meningococcal disease, including meningitis and septicemia. This bacterium has a protective outer membrane that the immune system must learn to recognize and attack. On the other hand, the varicella vaccine is aimed at varicella zoster virus, a virus that causes chickenpox and shingles. Unlike bacteria, viruses like VZV do not have a cell wall. Instead, they use a host cellular machinery to replicate. Despite these differences, both vaccines train the immune system to recognize and combat these harmful invaders effectively, significantly reducing the incidence of diseases they cause.